Okay, let's just dive right into this explainer. Today, we're unpacking the International Space Exploration's timeline. We're tracking over 80 years of history here, going from what was essentially a frantic Cold War sprint to this incredibly magnificent scientific marathon. It is just an absolute roller coaster of a story, full of wild ambition, heartbreaking tragedy, and honestly, unparalleled human ingenuity. Let's get into it. Here's our agenda for the explainer today. We'll start with the space race begins, move into the cost of the race, hit one giant leap, explore the endless frontier, and wrap things up with the next generation. All right, Section 1, the space race begins, the starting gun of the Cold War. So, to really grasp how spaceflight kicked off, we have to look back to the fallout of World War II. It literally all started with the V-2 military rocket in 1944. That was the very first man-made object to cross the 100-kilometer threshold into space. Post-war, both the Soviet Union and the US scrambled to repurpose this tech. But as you can see here, the Soviets absolutely dominated the early board. In 1957, they launched Sputnik 1, just this tiny, polished sphere broadcasting radio pulses, which, by the way, completely terrified the West. Weeks later, they sent Laika, a stray dog from Moscow, making her the first animal in orbit. And then the big one, 1961, cosmonaut Yuri Gagarin becomes the very first human in space. Meanwhile, the United States was totally caught flat-footed. When President Kennedy gave this famous address to Congress committing to land a man on the moon, the U.S. had exactly 15 minutes of human spaceflight experience. 15 minutes! Kennedy threw down this monumental, seemingly impossible gauntlet to counter the Soviet lead. To put this in perspective, the computing power NASA had back then was basically non-existent compared to the smartphone you've got in your pocket right now. I mean, nobody even knew if a moon landing was technically possible, let alone if they could pull it off in under a decade. Moving on to Section 2, the cost of the race, the tortoise and the hare. You see, this absolute obsession with achieving technological superiority came with a really deadly price tag for both sides. What's fascinating is how this slide contrasts the two engineering philosophies of the era. You've got the reckless speed of the Soviet hare versus the much more calculated, heavily tested approach of the American tortoise. The Soviet program was driven by these rapid, high-pressure propaganda deadlines. Often, they'd literally draw up designs on paper and just build them right away, skipping crucial safety tests. NASA, on the other hand, while still sweating under Kennedy's massive deadline, took a much more methodical, step-by-step approach. But honestly, both methods were pushed to their absolute breaking points. And we see the devastating results of that pressure throughout the 1960s. Both programs suffered immense, heartbreaking tragedies on the ground and in orbit. It proved pretty quickly that the vacuum of space, it is entirely unforgiving of rushed deadlines. The Soviets had the catastrophic Nedelin disaster in 1960, where a rushed rocket just exploded right on the pad, killing 54 people. Then the US faced its own darkest hour in 1967, when a spark inside the Apollo 1 command module, which was filled with pure oxygen, killed astronauts Gus Grissom, Ed White, and Roger Chaffee during a routine ground test. Just a few months after that, Soviet cosmonaut Vladimir Komarov was killed when the parachutes on his hastily built Soyuz 1 spacecraft totally failed during re-entry. Look at this quote from Alexei Leonov. Early spaceflight was just a terrifying gamble. When Leonov became the first person to walk in space back in 1965, some really basic physics got overlooked in the rush. Just imagine the sheer panic of stepping out into the void, only for the vacuum of space to instantly inflate your pressurized suit like a giant, rigid balloon. The guy couldn't bend his joints or even fit back through the airlock. He only survived because he made the insanely risky choice to vent his own oxygen supply out into space just to shrink the suit down. Like he said, everything was absolutely on the edge. All right, Section 3, one giant leap, the climax of the lunar race. Heading into the late 60s, NASA's methodical redesigns following that awful Apollo 1 fire really began to pay off. They didn't just point a rocket at the moon and cross their fingers. No, they built this incredible staircase of rigorous test flights to get there. Apollo 7 proved the redesigned command module actually worked. Then, Apollo 8 took the unbelievably bold step of flying a crew all the way to lunar orbit. Apollo 9 tested out the super fragile foil-wrapped lunar module in Earth's orbit. And finally, Apollo 10 was the ultimate dress rehearsal, taking that module just 9 miles above the lunar surface to map out gravitational fields. And before humanity even touched the lunar dirt, Apollo 8 delivered this profound perspective-shifting moment. This is the famous Earthrise photo. Seeing our shared, incredibly fragile home floating silently in the dark void, it was this beautiful, unifying moment at the end of 1968, which, if you know your history, was a year utterly torn apart by bitter divisions, war, and assassinations back on Earth. Then, the summer of 1969 hits, and the whole tortoise and hare race comes to a head. The massive Soviet N-1 moon rocket, which was plagued by rush development, suffered these catastrophic explosions on the launch pad. Meanwhile, America's Apollo 11 launched flawlessly. But guys, the landing itself, absolute nail-biter. Alarms are blaring, the guidance computer is overloading. Neil Armstrong literally has to take manual control to fly the lunar module over this massive boulder-filled crater. The fuel gauge is dropping to empty. They had mere seconds of fuel left when they finally touched down. Watched by literally 600 million people, Armstrong and Buzz Aldrin pulled off the lunar landing, perfectly fulfilling Kennedy's impossible promise. They spent over 2 hours out there gathering these ancient rocks. And here's a crazy detail. When they got back inside the module and took off their helmets, they said the abrasive lunar dust clinging to their suits smelled exactly like spent gunpowder. They completely cemented their names in history that day, while Michael Collins kept this incredibly lonely vigil, orbiting all by himself on the dark side of the moon. But as Apollo 13 showed us just a year later, spaceflight is never, ever routine, right? 2 days into their mission, an oxygen tank explodes, turning their ship into a freezing, dying shell. Surviving out there ultimately comes down to pure human ingenuity. The crew worked nonstop with mission control, using the lunar module as a lifeboat. It's just this brilliant testament to raw engineering instinct. I mean, millions of dollars of cutting-edge tech failed them, but they survived the trip home by hacking together a makeshift carbon dioxide filter out of actual cardboard, a sock, and some duct tape. Just incredible. Okay, Section 4, the endless frontier, probes, telescopes, and stations. So after Apollo wraps up in 72, the whole vibe changes. We pivot from this frantic nationalistic sprint into a much more collaborative, international marathon of pure scientific discovery. As you can see here, robotic probes start doing the heavy lifting in places way too dangerous for humans. Pioneer 10 becomes the first object to hit solar system escape velocity. The Soviet Venera 9 probe actually survives the 900-degree heat of Venus just long enough to snap our very first photo of another planet's surface. And in 1997, Pathfinder drops Sojourner, putting the first ever robotic wheels on Mars. As we move through the late 20th and early 21st centuries, there's this massive shift toward building permanent orbital habitats. The Soviets launched Salyut 1, our first space station. Eventually, that evolves into the International Space Station, which is this monumental, collaborative mega-project between 5 different space agencies, zipping around the Earth every 90 minutes. We also put the Hubble Space Telescope up there, completely changing how deep we could see into the universe. And in 2012, Voyager 1 does the unthinkable. It crosses a threshold no human-made object ever had, entering interstellar space. Which brings us right into a golden age of astronomy. Over the last couple of decades, our robotic eyes in space have gotten so much sharper and way more daring. Connected by a global network of scientists, we mapped literally 100% of Mercury with the Messenger probe. We flew right through Saturn's icy rings with Cassini. We actually dropped a lander onto a speeding comet with the Rosetta mission. In 2015, New Horizons gave us our first close-up of Pluto's icy mountains. And by 2019, that same spirit of global cooperation allowed a massive network of radio telescopes to achieve the impossible, capturing the very first direct image of a black hole. Finally, Section 5, the next generation, returning to the moon and beyond. So what is next? What happens as humans prep to leave low Earth orbit once again? Well, building heavily on Apollo's legacy, NASA's Artemis program is our next massive milestone. But listen, Artemis is not just about planting another flag and packing up to go home. The goal here is establishing a sustainable, long-term human presence on the moon. We are going back to figure out how to actually live on another celestial body, using the moon as the ultimate stepping stone. It's the training ground to prepare humanity for our next truly giant leap, crewed missions to the Red Planet. As we wrap up this explainer, I want you to just take a step back and look at this entire timeline. Over the last 80 years, we went from launching a V2 rocket that barely scraped the edge of space to literally walking on the moon in just a quarter of a century. Since then, we've touched comets, we've mapped dwarf planets, and we've peered directly into the abyss of black holes. So here's my question to leave you with. If we achieved all of that in a single human lifetime, Are we even prepared for what we might find when we finally set foot on Mars? Thanks so much for joining me on this explainer. Keep looking up.